H.264 MPEG-4 AVC technology. This is so important. That is why this lecture will focus on this. The H.264 is the MPEG-4 Part 10 AVC protocol. When we say AVC, we're talking about Advanced Video Coding Technology. It is the most popular standard for video recording, compression, and distribution. And that is why it is used in Skype and also YouTube. So therefore, you need to know this. Overall, in the specifications, this was developed by the project partnership of the JVT, the Joint Video Team of the ITUT, VCEG, and the ISO IEC JTC1 MPEG group. Looking into the details, there's many acronyms and very powerful international standardization groups. With the ITUT, the ISO IEC JTC1. Their descriptions are listed down here. This was designed for high-quality video with lowest bit rates. The video standards that uses block-oriented motion compensation compression. So it is the compression technique that is based on motion compensation based on block-oriented units, selected block units. And this compression technique is so good because you look at a video with sufficient resolution and quality. However, the compression technique makes the file size very small, in which it is easy to store and also very convenient to transfer over a network. So these two characteristics make it so popular such that Skype and YouTube and almost all video streaming and applications use it. So we need to go into further details. H.264 was designed to have half or a lesser bit rate compared to the MPEG-2, the H.263, or the MPEG-4 Part 2. And it was to achieve this half or lesser bit rate, resulting in much easier to transfer over the network or much smaller file sizes when saved in the memory. And this was accomplished without increasing the complexity too much. However, there was an increase in the complexity. Not too much, but there was. And the slight increase in computation complexity, consider that modern devices have better GPUs and CPUs such that they can take it and complete it within the same limited amount of time. H.264 is a family of standards, so it's not just one type. It has a group inside that composes several different video encoding profiles. The H.264 decoder may not be able to decode all profiles, so the decodable profiles need to be informed. Then, H.264 compression results in low bit rates and lower resolutions. The H.264 lossless encoding is possible but is rarely used because it will result in a larger file size. H.265 is the MPEG-H Part 2 and the HEVC, and this is a successor of the H.264 MPEG-4 AVC. The applications include Blu-ray discs, internet streaming sources, and that is why YouTube, Skype, iTunes Store, and Vimeo are all included. Web software for Adobe Flash Player, as well as Microsoft Silverlight and others are included. HDTV broadcasting companies use it as well. In addition, cable services also use it, as well as satellite services based on DVB-S and DVB-S2. The H.264 patents are owned by various parties whose licensing is administered by the patent firm, the MPEG LA, which is in Denver, Colorado, in the United States. The profiles include a non-scalable 2D video application profiles, which are the CBP, which is Constrained Baseline Profile, for low-cost applications used in video conferencing and mobile applications. Then there's the Baseline Profile, BP, for low-cost applications that require additional data loss robustness. And this is used in video conferencing and mobile applications as well. Then there's the Extended Profile for streaming video, where relatively high compression capability with enhanced robustness to support data losses and server stream switching. The MP, the main profile, is for standard definition digital TV broadcast using MPEG-4 DVB standards. MP is used for HD TV, but rarely is used after HP, the high profile, was developed in 2004. Then there is the high profile, which we were talking about, for DVB, HD TV broadcast, and disk storage applications. This is used as the Blu-ray disc storage format and the DVB HD TV broadcast services. Then there's the progressive high profile, which is similar to HP without the field coding features. Then we also have the constrained high profile, which is similar to the PHIP without the B slices included. There's also the high 10P profile, which builds on the HP with added support for up to 10 bits per sample of decoded picture precision. Then there's the high 422p, and this is for professional applications that use interlaced video. This builds on the high 10p with added support for the 4:2:2 chroma subsampling format while using up to 10 bits per sample of decoded picture precision. Then the other mode is the high 444pp profile. This builds on top of the high 422p, supporting up to 4:4:4 chroma sampling with up to 14 bits per sample. The H.264 profiles also include camcoders, editing, and professional application profiles, where 4 additional interframe only profiles used mostly for professional applications involving camera and editing systems. These profiles are listed down here. There is also the SVC, the Scalable Video Coding profiles, where Scalable Constrained Baseline Profile is one of them, primarily for real-time communication applications. There is also the Scalable High Profile, primarily for broadcast and streaming applications. In addition, there is the Scalable Constrained High Profile, which is primarily for real-time communication applications. The Scalable High Intra Profile is for production applications constrained to all intra-use. There is also the MVC, the Multi-View Video Coding Profiles. Stereo High Profile is one of them. This is a profile for 2-view stereoscopic 3D video. The Multi-View High Profile is for 2 or more views using both interpicture, which is temporal, time-based domain, and MVC interview prediction. There is also the multi-view depth high profile as well. These are the references that I used, and I recommend them to you. Thank you.